It's Andre from High Performance Academy here. Let's check out what's been going on around HPA over the last week. And we'll actually start with our giveaway, which is running. And we can head across to my laptop screen. This is the page you can get to if you go to hpaacademy.com/giveaway. And Geordie will drop a link into the comments as well, so it's nice and easy for you to follow. But we've teamed up with Haltech, and they have given us one of their awesome NEXUS R3 vehicle control units to give away. So this isn't just an ECU, it also includes a built-in power distribution module, or PDM, PMU, depending how you want to refer to it. So it's really sort of a all-in-one solution to vehicle control. Now, it is a little bit stripped down in that you are absolutely not going to be able to run all of the power demands for your car through the R3. But really what it's designed to do is take all of the power requirements for actually operating the engine and direct ancillaries and allow it to control all of those. So I'm talking here about things like your fuel pump, your thermofan, power supply to the actual circuits of the engine, such as 12 volts to the injectors, the ignition coils, boost control solenoid, those sorts of things. So it's very much going to be a one-stop shop for everything to do with your engine. For those who have been living under a rock and don't know what a power distribution module is, this is a simple way of removing the traditional fuses and relays that we see when we're normally wiring up a vehicle. Instead, everything is done with solid state electronics. There are significant advantages to doing so. First of all, it dramatically simplifies our wiring. It is time consuming to wire up a bunch of relays and fuses. It's difficult to do this and make it look really neat and tidy as well. But more importantly, from a functionality standpoint, with a traditional fuse, if we go over current slightly and that fuse pops, it is a mechanical link, and in order to reset everything, we actually need to physically stop, remove that fuse and replace it. With a power distribution module, we've got a lot more flexibility in terms of setting the current level that the system will trigger on or trip out, and also the ability to retry a circuit a certain number of times in order to give us a little bit of redundancy. And in a race application, it might be enough just to creep us back to the pit so we can actually effect a proper repair. The ECU side of things is really everything you'd expect from the Haltech NEXUS range. It is a fully functional ECU, ideally suited to vehicles with up to 8 cylinders or 4 rotors. So that kind of really defines how many ignition and fuel injector outputs you've got, so you're able to run full sequential injection and direct spark on 8-cylinder or 4 rotor engines. As well as that, we're also including our VIP package, and that is every course we currently offer. You'll also get free access to every course we release in the future, so you'll never pay for another course in your life. Total value for this giveaway over $5,000 US. It is a cracker. Ideal if you're thinking about an ECU upgrade for your vehicle, or maybe you're planning a project car build. Get your name into the draw. There's no catches here. You don't need to purchase anything. It is very simple. Head to that page, hpaacademy.com/giveaway, and get your name into the draw. I think this one has just gone live, and yeah, we've got 15 days left to enter. Now, it doesn't matter whereabouts you are in the world. We quite often get asked about this. We will ship this to your door free of charge. So don't think because you're in Tanzania or Canada or wherever you may be that you are not eligible. 100%, it doesn't matter where you are in the world. We will get this to your door. All right, moving on. I just wanted to cover an aspect that isn't discussed too much, unless maybe you've been following HPA for a while, because I am pretty passionate about this topic, and this is Lambda or wideband air fuel ratio controllers. So I've got a couple of exhibits to put up here under our overhead. This one here is actually a little bit advanced. This is the AEM 4-channel wideband. We had this back on our engine dyno, which we ended up decommissioning a few years back, and I do believe that AEM have actually stopped producing these, so it's a bit of maybe a bit of a museum piece, but as its name implies, it is a 4-channel wideband setup, which is allowing you to put individual cylinder lambda on each exhaust primary of a 4-cylinder engine. Of course, you could put 2 on a V8, allowing you to check individual cylinder mixtures. Key point of this is traditionally, well, this does actually have CAN bus enabled in it. Traditionally, this would output the lambda or air fuel ratio data as an analog voltage. So depending on the controller specifically that you're dealing with, this could be a 0 to 1 volt output, or more likely a 0 to 5 volt output. The idea behind this is you then wire this into an analog voltage input on your ECU, configure it as required, and then you're going to get air fuel ratio data being displayed on your ECU control software. You can data log it, etc. You can use it for tuning. All great things. Also, most ECUs these days can use that data for closed loop lambda control, meaning that if the air fuel ratio varies a little bit from your target on a day-to-day basis, it's going to be able to trim plus or minus a little bit and get you back where it should be, much like most production cars do these days. So again, all good stuff. The problem that I have with analog voltage-based wideband controllers is that they are very sensitive to ground offsets. Now, ground offsets simply mean that the voltage that the controller is outputting, let's say it's outputting 2.5 volts, or it's trying to output 2.5 volts. Depending how you've grounded the ECU and how you've grounded the wideband controller, you can end up with an offset to that voltage, meaning that the ECU isn't actually seeing 2.5 volts. Now, why that's a problem is that when you are scaling the output from this into your ECU, 2.5 volts is going to relate to a specific air fuel ratio. So I don't know, maybe it's 11.5 to 1 or something of that nature. So when the voltage that the ECU is seeing is not 2.5 volts, all of a sudden we're not seeing the correct air fuel ratio. We could be a little rich, or we could be a little lean. We might be a lot rich or a lot lean. And the problem is, when we're actually seeing a nice stable number on our laptop screen, it's really easy to believe that. And particularly for a unit like this one, we don't have an auxiliary display on the unit that's showing us what the actual air fuel ratio is that we can compare to what's on the laptop screen. Long story short, this can leave us in a situation where we are tuning off false data in terms of the actual air fuel ratio the engine's running, and obviously that can be incredibly dangerous. So what is the solution? Well, for probably the last 5 or 6 years, the only wideband controller that I would personally use is one that is CAN based. So again, got a couple of examples here that we'll get up under our overhead. This one here is a MoTeC LTCD Lambda to CAN. The D stands for dual. It's got 2 channel inputs, which we can see here. So ideally suited for a V configuration engine, for example. The other one that I've got here, I'll just grab. This is a Haltech equivalent of the same sort of module. It's got a bit of a longer lead on it for our wideband, and basically we've got 2 4-pin connectors on the underside of this. Interestingly, also the 4-pin connector on the MoTeC Lambda CAN dual unit. So why do I like CAN-based controllers so much? And I will also mention this is a sample size of 2. Most of the mainstream ECU manufacturers these days are producing their own equivalent. So I just grabbed what was available within arm's reach in the workshop, but don't think that these are the only 2 products on the market there. So what this does is it is a conventional Lambda controller. So it does all of the hard work of controlling the heater element and the wideband sensor, and then it outputs the air fuel ratio data as a CAN message. So the nice thing about this is that there is no potential for ground offsets getting in the way. The CAN message data is basically guaranteed to be stable, and going as long as we've obviously got the correct CAN template to identify and decode that data. The numbers that we get out of it in terms of lambda or air fuel ratio units are guaranteed to be accurate, or in other words, exactly what the controller is outputting. So we don't need to worry about whether or not the air fuel ratio numbers that we're looking at are in fact real. They will be. The other advantage of these CAN-based controllers is that they give the opportunity for a lot of diagnostics. As we probably all know, these lambda sensors do not last forever, and as they degrade, they can start to give erroneous signals, or they can drop out completely. Conventionally in the older days with analog based sensors, the ECU really has no diagnostics checking on the Lambda controller. So if the sensor goes full scale, either max rich or max lean, which can happen, and you are running closed loop, then the closed loop system can be trying to add a lot of fuel offset in order to get it back to where it should be, where in fact it's actually just responding to complete garbage data. With these CAN-based controllers, we have the ability to send diagnostic data to the ECU, and then the ECU can choose to ignore the sensor input and just run an open loop mode if it's deemed that that sensor is faulty. Also, a few other nice little functions we can do with these. The communication bus is two-way, so the wideband controller can also take in information about engine RPM, just as an example. And why this is important is that if you want to prolong your sensor life, and wideband sensors are expensive, so we absolutely do, we don't generally want to heat the sensor during cold start. We really want to allow the engine to at least start and run for a period of time before we bring the sensor online, and that helps prevent moisture damaging the hot sensor itself. So it's not bulletproof, but it definitely does help, and that two-way communication with engine RPM is a really good way of achieving that. Nice thing as well about CAN-based products is that as long as you've got access to the CAN template, which a lot of the manufacturers will provide openly, you can mix and match. So in other words, I could take this MoTeC LTC and I could use this with, let's say, maybe a Link ECU. Now, that's not always the case. A lot of ECUs are quite locked down in their CAN templates, but that is one example where we can mix and match. So quite a nice function there, and generally they're not going to be any more expensive than a analog based wideband controller these days. Another nice advantage with these is really simplifies the wiring. All we're doing is providing 12 volts in ground, as well as CAN high and CAN low, and that goes into our 4-pin connector, and our job is done.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.